Good morning, this is your Stat Sensei, Mr. Spensei, and this is another chi-squared test assignment. And this is generational genres, which is the other scenario that we looked at in the warm-up. So a major streaming service is analyzing user data to improve its movie recommendation system. While the platform currently suggests films based on viewing history, executives suspect that movie genres preference may vary by age group. So we had genre and we had age group, and those were our two variables in our sample. If a relationship exists, they could refine the recommendation algorithm to provide age-specific content to suggest and enhance the user experience. To investigate the service randomly selects 870. I know yours says 600, so scratch it out, write 870 from its more than 5 million customers. So we have a sample size of 870. We need to fix that here as well, and this needs to be 870. And we have a population of greater than 5 mil. And ask about their favorite movie genre. They also recorded the user's age group. At alpha 0.05, is there statistical evidence that movie genre, preference, and age group are independent? So we're running a test of independence, and we know our alpha level is 0.05. Well, the very first thing I ought to do when running a test of independence to go, all right, we'll go to, excuse me, second quit. We're going to go to blue matrix and, and here I'll do that real more slowly this time. Press the blue button, and then I'm looking for the matrix button, press enter. I'm going to go over to edit, and I need to input all my observed values. Now make sure you're inputting the observed values, none of the totals. So in this case, I have 1, 2, 3, 4 rows and 1, 2, 3, 4 columns. So I'm inputting a 4x4 matrix. So I'm going to press edit, 4, enter, 4, enter, and then I went 80, 70, 50, 30 all the way across until I got all those in. So take a moment, get that in. Once you have that entered the matrix, press blue button mode, and that clears the screen. Now, this seems a little bit weird since we're getting ahead of ourselves just a little bit. And we're going to go stat test and scroll down to letter C, and we'll go chi-squared test. Observed, expected, calculate. And at this point, we get a whole bunch of information. And so I'm going to kind of skip ahead and come back to what we were supposed to be doing in just a second, okay? So first off, we'll come back and we still don't have those expected values, but we're going to go ahead and write our formula. Observed minus expected squared over expected. And we can go ahead and draw our graph at this point because we know it's always going to be skewed right. It's always going to start at 0. It's always going to go to positive infinity if we're working with any of the chi-squareds. In this case, we got a chi-squared value of 53.6 and a p-value. And if I notice, I have a -8 out here. Well, that means this area right here is 0.000. It's going to be approximately 0. So our p-value is approximately 0. So we have all of that. It also gave us our degrees of freedom. I'm going to come back and talk to you about our degrees of freedom. We're going to make a note of it right now, but I will talk to you more about that in just a second, how they got that. But degrees of freedom equals 9. So we're going to make a note on that. All right. So at this point, when I look at this, it's like, okay, I've got everything except I don't have my expected values yet. How do I get that? Well, I'll go back to my blue button and we're going to go back to the matrix. Blue, matrix, arrow over to edit, and we're going to drop down to letter B. And at that point, we see that we have all of our expected values and we record them into the table. And that's going to take a lot because that's a lot of recording right there. And please remember to scratch out that number and write 870. All right. Well, if this is our formula and we're going to just plug in our first and last one, we might as well go ahead and do that. So when I go to plug in my first is 80 because this is my observed and this is my expected. So observed minus expected over expected plus, then we're going to skip to the last one. So basically, we're only going to mess with, or we're only going to use the first one, and then we'll also use the last one. Where this is my observed, this is my expected, and this is my expected. All right, so we have that part done, but where do the degrees of freedom come from? Well, degrees of freedom comes from rows minus one times columns minus one. Well, how many rows? 1, 2, 3, 4. So 4 minus 1. How many columns? 1, 2, 3, 4. So 4 minus 1. Well, what's 4 minus 1? Well, 4 minus 1 is 3, and 3 times 3 is 9. So our degrees of freedom is 9, and that's where that came from. All right. This is a chi-squared test of independence. Some people put TOI, which is great, but you always have to write this out at this point. Don't abbreviate here. Put chi-squared test of independence, but if you ever see a TOI, you know that that's what they're asking for. All right. Our null hypothesis and alternative hypothesis. Well, null will always be it is independent. So movie genre and age groups are independent. All right. Please notice they are not associated. All right. Are independent, but they're not associated. On the other hand, when we get to the alternative, it's the same word. Our variable one, movie genre and age group, movie genre and age group are, instead of it being are independent, they are not independent. And they are associated. So everything's the same, except these are opposite, exact opposites. One is are, the others are not, and vice versa. Okay, please don't mess those up. That's a huge deduction. You lose 10 points right there. Sorry, still getting over pneumonia. Conditions, random sample. Well, we had a random sample of what size? We had a random sample of 870, and that was given. All right, so we're good with that. But we need to make sure that our sample size was not too big. So we went 870 times 10, and that's 8,700, and that's less than 5 million. So N is less than 10% of the population, right? And then the third one is it big enough? Well, all expected values greater than 5, see table above. Well, if we go check our table above, the smallest one was 34. So definitely all expected values greater than or equal to 5. All right. Probability statement. So the probability of our chi-squared value being greater than 53.6 is approximately 0. And you go, well, wait a second. I know you wrote that on the graph, but how did you actually get that? We went stat, test, chi-square test, 53.6. And remember, check that E. If we have an E there, we need to put 4 zeros or more in front. In this case, we need 7 zeros. So the probability that our chi-squared is greater than 0 is about 0. Greater than 53.6 is approximately 0. Well, 0 is definitely less than our alpha, so we're going to reject our null. So our conclusion, our p-value is approximately 0, which is less than our alpha 0.05. We reject the null. There is sufficient evidence to suggest movie genres and age groups are, I would prefer to say, and so I'm going to scratch this out, are not independent, and are associated. All right. Now, where did that all come from? Not independent and are associated. Let's go look at our alternative hypothesis because that seems where everything always comes from. Are not independent and are associated. All right. So we basically said, hey, there is sufficient evidence to say they're not independent and that they are associated. All right. I hope this helps and look forward to seeing you on the next one. Thank you.